Well, tonight's a different setting. We're in an apartment tonight. And I've been pretty mobile most of my life, so I'm used to be able to move around. But this is an interesting book I came up with, got recently. It's a library book, but it's an up-to-date book. It's put out by the CRSC Press, Taylor and Francis Group. It's put out by asit bhattacharyy, I think he's Indian, and Jeffrey M. Lictman. It's called The Solar Planetary Systems. This book was put out back in 2017. So this is about a lot of recent information. The only thing it didn't have is the up-to-date information on the Juno mission to Jupiter, and it did have the stuff on Pluto, so what they discovered on Pluto with near horizons. But here's what the book cover looks like, and it's a interesting combination because the author is a PhD in physics out of India, and then it was Jeffrey Lictman, who's a specialist, kind of like what I am, who started the I guess he's probably been part of SETI because he specialized in the military and radars and missile control system and stuff, Jeffrey Lictman. So it's kind of a, show you the relationship between physicists and the electronic wizards out there. But anyways, the book covers a lot of the stuff they discovered on the solar system. How they've sent out. Last count, I got a book on all the missions that NASA sent out. It's something like, about 80, 85 missions, maybe 85 since the 1960s when all it began. And the Russians put up the put up Sputnik. So it's been it's kind of a combination of a lot of years of gathering data. So it's pretty up to date as far as data goes. The only thing I don't agree with is the stellar evolutionary theories. There's nothing done by stellar evolution out there. It's all done by design. Just have faith in engineering and some new advancements in science that ET can operate out there in the universe with galaxies and everything else. So, but I was telling about one of my other discussions about being able to move planets. There is some science evidence to indicate that the ET does have the ability to move those. There are theories on it that it's just natural gravitation, that they just drop out of orbit and there's orbital decay and stuff, and it just happens. Something that happens. The Jupiter starts out there in the outer solar system and just moves in. But there's nothing. They really can't explain how gravitation will do that, and I don't think that's what. There's a thing in general relativity that says you can actually warp space. There, we don't have the engineering to do that. It's only theoretical science, but you can actually warp space and actually roll. A planet's just a ball, and once you can warp space, you can actually start rolling that planet just like a snowball, and rolling it, and get it going to where you want to go. You only got to get it out so far out of the Earth's gravity. There is stuff that they've discovered out there that just planets that are stars that, I mean, usually it's like a planet or something that's just in between solar systems. That's just, you know, they can't, it's just out there. And what are they, and you know, what are they doing out there? And my suggestion is that they're moving planets out there, or planetoids, not really planets, but just planetoids, and moving wherever they need them. So there's some indicator of that. But the problem is we don't have the kind of telescopes and observational data that would actually, I could actually prove that that's what those are, you know. So that's, you know, that's one of the things. This book starts out with one of the things I've actually marked here is one of those objects called Sedena, designated 2003 VB12, was discovered by Mike Brown at Caltech, astronomer and colleagues Chad Trujo of the Gemini Observatory and David Ramonitz of Yale University on November 14, 2003. The object is 90377 Sedena 520 AU average from the Sun, is a large reddish object with elliptical orbit that takes it above 76 AU at perihelion to 94 AU at Ophidian, taking it 11,400 years to complete the orbit. Sedena is not part of the scattered disk or the Kuiper belt, as Ophidian is too distant to have been affected by Neptune's migration. Sometimes it is also termed distant detached objects. Brown's termed this population as the inner Oort cloud. Sedena is similar to a dwarf planet, though its shape has not yet been determined. So what does that tell you? That they don't really have any way to visualize. Hubble's not going to be able to give you a good detailed image of it, and there's no earthbound telescope at this time that we have that's going to be able to give you any kind of image of one of those planetoids that far out, let alone another star. So, you know, there's a lot of distance out there that, you know, we don't have the ability to do and find out there. It's just so it's not it's just a lot of it's like a lack of science funding. There seems to be always a lack of science funding to be able to put out those kind of, I would call them trying for the wheel science projects where you can actually, you know, get some really good data and stuff out there as to what the universe is. Part of the problem is they promoted evolution out there, and that there's just random events out there, and there's nobody actually living. So how do you promote science out there when it's a dead universe, or even their Big Bang theory that what they promoted within the Big Bang theory? All they noted was a dead universe. That there's nothing out there that can actually utilize all that. There's no hand of God can actually mobilize all that. So here again, tonight I've got my candles lit and I'm going to celebrate the craft. You notice that I don't do broadcasts on UFO conspiracies and stuff because all they are is drones. You couldn't fly one. You would take a trip on a drone. As soon as it took off, all the fluids in your brain would go to the back of your head, and you would pass out, and you would die of just be plastered on the back of the craft. You couldn't take the G-forces. This human body cannot take the G-forces of running around in a flying object. But all those are being utilized, and it's pretty obvious what the U.S. military uses for Predator drone for is it's an observation platform. So ET's very clever, something the Air Force can't shoot down, and the extraterrestrials can use as observational platforms. And they've also, you've seen and noticed recently that they've got up on the space station, they're being observed up there also. So those are already out there. We just don't know who's operating those. So, anyways, something else. Chemical memory of the brain. See me having to do this? There's a better design out there. I don't think this is the original brain, and I think there's improvements that can be made on it. So there's a lot of money science funding these days going into neuroscience research and stuff, and how to make improvements on the performance of the brain, which I support. Mr. Gates, I think, is the one at Microsoft been financing some of that, because he discovered when they put all his features into Microsoft and stuff, and we found out people only using about 22% of it. So, you know, it's one of the problems with the human brain is you put all those engineering features in there, is that most people aren't using all that because that's just not how people, this brain really isn't the utilization of all those factors into it. There's another factor that goes into that. But anyways, there's what ET I think utilizes out there is they put on like a headset and they can actually, this becomes more of a, it's not too far in the future, it's going to be called engram science, where you can actually enhance the brain's memory process, even though it's chemical memory, and you don't have to do as much of this as far as memorization goes and stuff. It's one of the reasons why medical doctors get sued. They've left school and they know all the procedures and stuff, but they don't know the nitty-gritty anymore. They've lost it. Spent 8 years in college, but this is the human brain, you know. So there's a lot of money being spent on neuroscience these days, which is good, and I would admit it's a very good investment, even in fields like China. I've been reading some of the stuff that they're researching, and they've become kind of a leader in neuroscience research. So they're understanding the thought processes and how the brain is mapped and stuff. Some of that's going on down at the University of California, where their brain mapping technology is showing how the brain functions and how its neural processors function in different things. So there's a lot of good, there's some good research going on in improving the brain, because it needs to be, we're not the best deal out there in the universe, and this is a good example of it. Let's see, we're drinking purified water tonight. All right, but anyways, get back to the book here. Okay, yeah, origins of the solar system. There's a lot of, it was still stellar evolution that's being promoted. They've discovered planets, and they Summit, Pluto. There was arguments of whether it should be classified as a planet or actually just a planetoid. So I know why I marked this one. You add up the total number of planetoids and planets around our sun, about 1,800. A lot of those are asteroids and stuff. So they're an interesting little statistic, about 1,800 planetoids and planets in our solar system. A lot of those are just asteroids. Plus you got moons around the different planets and stuff. So that's quite a bit of stuff out there that's fairly good size, at least a mile in diameter. So that's a factor, is that when they're navigating around out there, I'm surprised they haven't really hit anything, because you know, all the satellite space dishes they've sent out there, anything that's a mile in diameter, it would smash the Voyager spacecraft or any of the Mariners or anything like that. If they were to hit anything like that, with the asteroid being a mile in diameter, it would totally disintegrate at the speed it's traveling. So fortunately, those aren't clumped together. They're pretty well spread out. So we've been lucky so far. I'm not the engineer out there, but I guess there is probably some kind of advanced warning system, a radar, or something that gives the craft the ability to change course rapidly if the radar detects an object of fairly good size. But I don't know. I wasn't part of the engineering team out there, so I couldn't answer that question. Well, we just actually been lucky. Yeah, I marked this one because it gets into stellar evolution and stuff. There's absolutely nothing out there that can make gas condense without some kind of artificial engineering out there to be able to do that. It's just like when I was in theater, when you put stage fog out on the stage, the only thing that I can utilize out there, if I don't want it just running around all over the set, I can make it stay on the ground by using dry ice, which is a cooler form of gas, and cool it, and it stays down on there. But I'm actually using a tool. I'm actually freezing the dry ice, and I'm actually putting it on stage, and the chemical reaction is what's creating it. But I'm the one that's doing it. So here again, you got design, because there's somebody out there, even the stage fogger, I'm actually utilizing, and you want to mobilize that gas for move it and stuff. You can put a fan out there and stuff, but it's all part of the show. So here again, their stellar evolutionary ideals are just, they're not good explanations as to how that happens out there. I think they need to be more, instead of promoting those kind of concepts, just say we don't understand the engineering and that takes place on how to do that. But there's another factor, and that is if you can electrify gas and stuff, but it takes a lab experiment. It's like they took a ball of gas and they were trying to replicate the primordial Earth. And it's ironic because they had to add electricity to it to create the effect, and they put these gases in there and they fired it up with electricity, which they were the ones providing. And then they were able to replicate something about what the primordial soup of the Earth originally was, and how lightning would actually integrate those gases into the kind of elements we'd actually need. But somebody out there actually had to put that out there. So, you know, here again, they really don't. I've did an electrical lightning, so I would recommend, if you really want to get into stellar, how all that works out there, read and watch my review on lightning, and because you need to really understand that that's a energy that we really need to understand, because it's part of the engineering out there. This page here gets into stellar disk. This is how they explain it. Milky Way galaxy is filled with cold, 10K clouds of molecular hydrogen gas as well as dust. Dust provides for condensation of gas as well as ice-covered dust. Well, there's something that has to clump that dust together. And I think electromagnetic radiation and stuff out there is part of that. Clouds begin to collapse under self-gravity, dust begins to accrete. Well, there's nothing out there. The dust accretes some, but it's not going to accrete enough to actually create planetoids. That's going to have to be actually created. It's like a room ionizer. You put it in a room and it collects dust for you, but that isn't going to create a planetoid. All it's going to do is create a nice mat of film, similar to what we had on the moon when Armstrong put his foot on the moon. It's a big famous photograph, and he puts it up there and he says those famous words about where one step, I don't even remember what he said, but anyways, you see how far he stepped into the dust, about that thick on the moon. So there's something out there that ET uses out there to utilize that and actually use it into a functional purpose. But anyways, let's see, clouds collapse to a rotating disk. Well, there's ways to create rotating disks where that's going to actually collapse, but you're talking miles and miles and hundreds of thousands of miles of debris out there. That's millions of miles of debris, and you're going to condense that into a planet. You're going to have to probably create an artificial black hole, something that has a lot of gravitational pull to it, that's created artificially, that's going to be able to mobilize all that matter and actually start creating a planetoid that you can actually create a planet from. And also you're gonna have to be able to mobilize the gas, and you're gonna have to create certain gas elements, which involves electrolysis, which we've talked about lightning again. You have to understand lightning, then you're gonna understand how ET starts creating planets out there. So we get into the goody stuff, you know. So, yeah, they call it dense matter class faster protozoans. Protozoans form for planets. And outer region evolves slower into the thin disk of particles and thicker outer disk particles of gas. Okay, so anyways. The whole image of a protoplanetary disk in the Orion Belt, they use that as an example. That is not an example of a protoplanetary disk. That's an example of something they create out there. And it has nothing to do with our solar system. It's something they clump matter and planets together and matter and stuff that they need to utilize it. And they put some kind of it's kind of a cosmic honeycomb that they create, and they can actually put those huge planetoids together and stuff. Or it could also be a possibility they utilize it. Could there a space colony out there? Let's say, you know, you cut a huge planetary out there, and you don't want to have it around the sun or something, and you want to keep it in and out of stellar space and use it as a platform for working within a nebula, and you want to run a space station out there. What you can actually do is you can put together a space colony out there close to the nebula and use that as a command center for your cosmic event going on there in the galaxy. So here again, because those are associated with nebulas where they're actually making suns and stuff. So that's my suggestion as to what we're looking at. It has nothing to do with protoplanetary disk or solar systems. They actually tested that glue, that honeycomb out there on the space station, and they were actually able to create it. But there's no explanation by NASA as to what we were looking at. So, that does it for that page. Okay, stellar wobble. Yeah, that's whether you got the two sun. The sun is going. You got the sun, and then you got planets rotating around the sun, and they're able to measure the wobble by what kind of gravitational pull is taking place on the as the planets go around the sun. It's not a very good method of accurately measuring size of those planets, what's their distances, because it's not very accurate at all, because they place them too close to the sun, and they can't explain as to why a Jupiter-sized planet would be that close to the sun. Well, it normally wouldn't be out there, because it'd be in the place where it is today, about so far away from the sun, or the size of our sun. So here again, it's not a very accurate means of actually measuring. It all it does is tell them there's actually planets around the sun. So it is good information, because it does give us some indicator as to what those that the sun does have some planets rotating around it. That the sun not just out there alone, which is what we want to hear. We want to know that there's some kind of planets being out there, and then there may be a possibility of life out there, over a sun being created out there, and there's no planets at all. I wonder how much that's the case out there. But I'm not running the observatory that's doing these studies, so I couldn't actually tell you. Okay, they're studying the nearby solar-like planetary systems. There's a scuba, what I call a scuba image with the position of the star and predicted position direction of the planet. So they can correct. There is some medium that's running around that's floating around the star, but it's not really. It's not going to show you whether there's going to be an Earth-like planet out there or how there's lack of visual astronomy and stuff. They don't have the kind of telescopes that you need to be able to discover that, or the optical systems that you need to be able to get that kind of detail and that kind of information. So. Here's some information on the scuba camera built at the ATC Astronomy Technology Center out of UK, was operated on the James Clerk Maxwell Telescope in Hawaii. The scuba image exhibits a disk of very cold dust in orbit around the star. The regular shape of the disk was the clue that it is likely to contain planets. Well, that could also, what that irregular disk could also indicate is they're not utilizing that disk for anything out there either. They don't have a hot Jupiter out there. It's actually they're not actually mobilizing the gas for planets yet. So, but anyways, this the so anyways, that's what they were using that. So that's just an added enhancement to a telescope. So a lot of these Earth-based telescopes can be enhanced by new developments in technology. So that doesn't mean they're not going to eventually get an answer out there with some new electronic engineers out there that actually can enhance the visual astronomy out there. So that doesn't mean, that the Earthbound telescopes are obsolete. They've also been able to correct atmospheric distortion. What makes the Earthbound telescope more accurate as far as accuracy out there and stuff. So, there's a chance of getting more information just by enhancing Earthbound telescopes. They got hot Jupiters. I'm not really going to get into that. As to what Jupiter's made for, their theories that they made out there on the outer system of the solar system, and they come in because because the theory on that is the reason why they think like that is because that's where the Kuiper belt is, and that's where a lot of your water ice and stuff and where comets are coming from, and it's not asteroid material that's in the comets, it's just frozen water ice or frozen gas, hydrogen, helium, and whatever. And so the theory is because of that's out there. We know the Kuiper belt is out there. That must have been where Jupiter was formed at. But I have another theory on that is that Jupiter can actually be moved, and so that might have been a possibility that where they created it at, but they just moved it in. It's not that's something they can actually, the ability to actually move planets and stuff to whatever function you want to is an engineering problem. So anyways, it gets into the hot Jupiters and stuff. Gives you good, shows you all the different hot Jupiters out there they've discovered. So they could mainly consist of rock dust up to 1.3 Jupiter radii, 0.2 Jupiter masses, as low as 0.3 grams CBM3. Moons are unknown. So that's something they actually have discovered out there. Here they get into their hot Jupiter tidal forces and stuff using using Newton's laws of gravity, but that's not the full story. Gravity, it's only a partial story, but it's been the standard foundation for a lot of physics out there. But it's not the full story because Newton's law of gravity, we would not be able to create artificial gravity. We'd actually never be able to leave the planet Earth. For it to be able to create artificial gravity is going to require a new type of physics. Someone that's going over gravitational research, I think Clea Irving is one doing that research. So I would recommend checking that site out, see what they're discovering. And it's going to take something new that's going to have to be discovered out there that's going to have to be added to their some of their physics theories to be able to create artificial gravity. But once you can do that, there's a lot of possibilities, not just in creating a gravity for a space station or a spaceship. You can actually mobilize bend gravity and stuff, or condense it to the point where you can actually move a planetoid and stuff to where you want to, create a quantum event. So here again, you also get into quantum physics and how you can move large masses. Let's see, detection of water vapor in hot Jupiters. There's a lot of good spectrometer data in here. Let's see. It says that the atmospheres of a lot of these hot Jupiters contain water vapor. So, you know, you got the Kuiper belt out there, and you got comets and stuff. So, you know, that may be where they create the Jupiter. I've been investigating that for quite some time, but I really haven't come to a conclusion yet as to why the Kuiper belt is out there in the first place, and the possibilities of why, what's the origins of it. Mainly because there's lack of data on the Kuiper belt. We never have been out there. All we have is periodic comets that come in, but it's just a belt out there that, you know, it's just lack of data. Basically, it's lack of data. So that's one of the reasons why I can't you can't really come to a good conclusion as to why that's out there until you can go out there and investigate it. And we have no spacecraft. The spacecraft we got out there, Voyager 1 and Voyager 2, but I don't think they hit the Kuiper belt. It's clouds out there, and if you don't send the spacecraft into the clouds, your chances of getting into that stuff are pretty slim. They don't want to risk losing the spacecraft. So I don't think even Near Horizons, they were planning on an extension mission with Near Horizons, which went to Pluto, and that was going to be the extension mission to actually visit the object of the Kuiper belt. So you actually get some data. My suggestion is that we need some kind of reusable spacecraft. You know, we saw the Stanley Kubrick movies, 2010, 2001 or whatever, where they actually built a reusable spacecraft that actually could go back to Jupiter and back, that's manned and stuff. But we need something that you can actually, that's built in outer space, that actually can go out there on distant missions and, you know, do some real science, do some real research. It doesn't have to be manned. You can put a robotic crew on there, and there needs to be something out there that you can actually touch out there and reach out and do some research on those asteroids, gather information on the asteroids out there, go out to the Kuiper belt, do investigations of that, and you know, they can put a robotics unit on one of those spacecraft and send them out there and to get their data too. They don't have to put a manned crew. It's fairly dangerous, you know, and I don't know how many astronauts would want to volunteer for something like that. It would take about 9 or 10 years of boring space flight. You can find in spaceship that's only so big, and then it's, 9 or 10 or 12 years coming back. So a good portion of your life is already over with, and it's kind of tedious work. And the more time you spend out there, it depends on whether they get artificial gravity as to whether they'll be able to do that. But they could put a robotics mission out there that doesn't require artificial gravity, so there's not like they could really put anything out there. It would be a possibility. Okay, they also talk about the different plasma out there. That's one reason why I marked this. I'm going to mention those. They're created by ultracode plasmas are producing a magneto-optical trap. The process is accomplished by trapping and cooling neutral atoms to temperatures of 1 MK or lower to ionize the atoms, thus giving each of the outermost electrons enough energy to escape the electrical attraction of its parent ion. One advantage of the ultra-cold plasma is they're well characterized and tunable initial conditions, including the size, electron temperature, adjusting the wavelength of the ionizing laser. The kinetic energy of the liberating electrons can be turned as low as 1 K. So, that's interesting. That's engineering out there. It shows you that they can actually mobilize that in a laboratory. So you're getting some clues at the possibilities of what that can be eventually used for. But here's like non-neutral plasma. The strength and range of the electric force and the good conductivity of plasma ensures that the densities of positive and negative charges in any sizable region are equal. Plasma with a significant excess of charge density, or in the extreme case composed of a single species, is called non-neutral plasma. In such a plasma, electric fields play a vital role. Okay, so that's actually something we can create. Dusty plasma and grain plasmas. Dust plasmas contain tiny particles charged to dust, typically found in space. The dust particles acquire high charges and interact with each other. Plasma that contains a larger particle is called grain plasma. Under laboratory conditions, dusty plasmas also termed as complex plasmas. So why are they studying that out there? Impermeable plasma. Impermeable plasma is a type of thermal plasma that acts like an impenetrable solid with respect to gas or cold plasma that can actually be physically pushed. The spectroscopic data on the characteristics of plasma are claimed to be difficult to get due to the high pressure and acid effects of plasma. So different nanostructures are suggested of the effective confinement. So now we're getting on how to roll on gas. So I think there's going to be some new theories on how the solar system came into being not too far in the future, if we're able to find a rhyme. But anyways, let's see. This section is pretty good. It's got some good information on the planetary atmospheres. That's the critical part of life on our planet and what we discovered on most planets. A lot of those planets do have an atmosphere, but that doesn't mean it's an Earth-like world that can support life. Mercury, 42% molecular height, oxygen, 29% sodium, 22% hydrogen, 6% helium, and 0.5% potassium. We can't live on Mercury. Venus, 95% carbon dioxide, 3.5% nitrogen, 15% sulfur dioxide, 7% argon, water vapor, carbon dioxide, helium, 7% neon, and trace carbonate sulfonate, trace hydrogen chloride, and trace hydrogen fluoride. we can't live on Venus either, but it is an Earth-like world. Eventually, it can be utilized if we figure out how to convert those gases and move it into the habitable zone of the planet of our sun. Doesn't mean Venus can be an Earth-like world. You have to be able to convert. You have to be able to convert atmosphere and be able to convert gases and stuff. Now we get into the planet Earth. 78% nitrogen, 20% oxygen, 0.93% argon, and 0.38% carbon dioxide. And about 1% water vapor, varies with climate. Now we can get on a planet we can actually live on. So we already know what the requirements are for human life, and so we only have one world right now that can actually support life in our solar system. We haven't really. They did test in Mars, but it's inconclusive. You know, they're looking for microbes on Mars. They did some tests with I think the Curiosity rover and some of the other rovers on Martian soil, but it was inconclusive. So there's not any strong evidence yet that Mars has life. So here again, Earth is really the only planet right now that life can exist on. Mars is 95% carbon dioxide, 2% nitrogen, 0.2% oxygen, 0.7% carbon dioxide, 0.03% water vapor, 0.1% nitrogen oxide, and 2.5 per ppm of neon. And it's also got krypton, formaldehyde, xenon, ozone, and methane. So these atmospheres are not, once if you're looking at the different atmospheres, there's no uniformity to it. They do have an atmosphere, but it's not consistent. You know, you're getting different concentrations of different gases and stuff. So, you know, I haven't come to a conclusion as to what the plans are out there and why those atmospheres were put out there. I'm not a chemist expert, but I think they're good. The research I would start out with, I am studying a little bit of chemistry, but I mean, you have to take these gases and you have to figure out what those gases can actually be converted into, as to what those planets can actually be used for, or what the plans are for those planets. You know, you take those elements and then you get your chemist experts out there and you figure out what those gases can be converted into and what they can utilize, what they can be utilized for. And that would give you some clues as to why that's out there. But it's something they have to answer. And there's chemistry experts out there that can analyze the gases and figure out, you know, why that's out there. But that should always be the goals of science, is discover what is the truth out there as to what that can be used for and why that was done. Here's Jupiter, 89% hydrogen, 10.2% helium, 0.3% methane, 0.26 ammonia, hydrogen dioxide, ethane, and water. And ice is out there. They have ammonia, water, and ammonium hydrofolate. So here's Saturn, another gas planet, but the hydrogen concentration on Saturn are 96% and 3% helium. On Jupiter it's 10%. So here again you have a different concentration of gases out there that were left out there, and you got methane, ammonia, and hydric deuteride. And you got ammonia, water, and ammonium hydrosulfide. Uranus, now we're out to Uranus, and we discovered a composition of 83% plus 3% hydrogen, H3. So that's a mixture. 15 plus 3% helium, and 2.3% methane. So obviously it's not the same gas composition as Jupiter and Saturn. And here again, you know, you have to think in terms of what those gases, what they could use those gases for, and what they utilize it for. It takes some people with chemistry and get out on the computer and stuff, and take these gases and draw line diagrams and figure out what that's going to be used for. You know, Neptune, you got 80% hydrogen, 19% helium, 1.5% methane. Pluto is nitrogen and methane. Let's here again you have to. It could also be a possibility that it was part of could have been part of creating the planet Earth. You know, if you're in a laboratory and you got all your gases on the periodic table and you got all your elements and stuff, and you're like, it's like creating an aquarium, and you want to create a biosphere and stuff. And if you can move planets and stuff, you know, you bring your laboratory out to the solar station, and then actually you can, you know, when you're creating an atmosphere you got a little bit of this and a little bit of that. It's kind of far-fetched, but that might be a possibility as to why that's out there. So I'm not really sure. You know, it could be used for fuel, to fuel a spacecraft. You know, it was left out there for a reason why that was done, but you have to put a clue together and a chemistry expert to figure that one out. Gamma ray burst. That's one of the reasons why I marked this. They don't really understand where those come from. They do know that they haven't had a strong gamma ray burst in the Milky Way galaxy, but they detect them in other galaxies. And I would wonder if that's a kill shot within a galaxy. They're just wiping out, you know, I don't know. Is it a quantum attack out there in the galaxy? You know, get your mirrors out, stack your mirrors up, because it kind of starting to look like that. But that, you know, they got different sources. Well, it's a black hole that's producing those, are merges of binary neutron stars and stuff, but they haven't actually seen that happen. All they do is detect the energy. So they don't have the ability to see where that's actually coming from in the galaxy, because there's nothing they have that can actually detect that. So you know, here again, you know, get your 6-pack of beer out, because, you know, it's a high energy event, and, you know, it is happening on some of the galaxies out there. They haven't detected it. So they find a quantum war, you know, I don't know. You have to get your 6-pack of beer out, because that, you know, it's not something it should be. Normally I don't think it usually is out there. It should be out there. So that's a 6-pack part of this book on quantum high energy physics and gamma ray burst. All right, Pluto. Pluto's an interesting one, because we finally got the near horizons spacecraft out there to Pluto. So now we actually got a visual picture of what Pluto looks like. So when you put all of our solar system together, Jupiter, Saturn, Uranus, Neptune, and you can go all the way out to Pluto now. So we got something to put in textbooks, so the kids in elementary school, in high school and stuff, can actually get a good view of the complete solar system outside some planetoids out there. So, you know, we got a good you know, we got it's kind of like the periodic table. We got a good you know, we got a good visual on all the solar system. Mission objectives of the New Horizons, it was actually a smaller spacecraft. They were going to use another one that's a little bit more expensive, but this one fit more into the budget, and they felt like it wasn't going to be necessary. So they put this one together. The primary objectives are to characterize the global geology and morphology of Pluto and Charon. They did get some good pictures, we've already seen those. Characterize the neutral, non-ionized atmosphere of Pluto and escape rate. I think they detected nitrogen. Let me make sure I'm right on that. I think they did discover, they discovered methane also. I think they discovered nitrogen. So it's, you know, here again, your atmospheres are inconsistent when you go through all the solar system. It's not consistent. So that also conflicts with their planetary, protoplanetary disk and stuff. Everything in our solar system came from a common source, but all their atmospheres are different. So there was something out there that was utilizing all that. It was created by design. You just have to figure that out as to what the purpose was in that. So it conflicts with their common theory on that everything in the solar system came from a common, you know, construction material. It's not, I don't think that it's exactly true. What else? Search for neutral species with such as molecular hydrogen, carbon, hydrogen. Search for any Charon atmosphere. I don't think they discovered any atmosphere on Charon other than water ice. I think they discovered water ice. Determined bolometric bond albegos for Pluto and Charon. Map surface temperatures of Pluto and Charon. Mapping additional surface of outermost moons. Image select Pluto and Charon. Map the terminator days dot border of Pluto and Charon with higher resolution. Map the chemical composition of select Pluto and Charon with high resolution. Okay, additional mission facts. The passed the moon after just 9 hours and reached Jupiter the following year. Took only 3 minutes to cross the diameter of Pluto. The first images being back revealed that the diameter of Pluto was 2,370 kilometers. So now they have an exact reference point of how big the planet is, but they can't do that, couldn't do that through observational astronomy. So here again, you're getting inaccuracies in their ability to measure distance to other galaxies and stuff, based even on observational astronomy. Until you go out there, you don't have an accurate means to measure distance out there. And Pluto is a good example of it. Now you know the exact, because they got visual evidence, they can have the exact diameter of Pluto. So until you go out there, the data and stuff, as the farther you go out, it gets a lot more inconsistent and stuff. So, you know, that's one of the problems with observational astronomy and stuff, and going anything outside our solar system, our ability to measure distance and stuff, is someday in the future is going to either be, say, well, we were totally inaccurate, we were partially accurate, you know, or we weren't accurate at all, you know, measuring distance. It's like the early ships, when we sailed around the world and stuff, their ability to measure all that was not accurate until they actually went out there. But we did get an accurate measurement of the planet Pluto, because we've actually been out there now. Yeah, they found methane ice on Pluto, icy mountains on Pluto. There's a lot of reference points. A lot of this is put out in science journals and stuff, and books like this. A lot of them never make it into book format, so You know, we still have good freedom of the access of information on the internet. And keep in mind, a lot of the stuff that's used to put these books together is just on the internet in science journals. So, you know, there's still good information out there and stuff, but you know, keep in mind that a lot of that stuff never ends up in a book in a format like this. This is a library book, and I don't know how well it'll sell out there in the open market. So, you know, that's one of the problems with depending on the internet. It's a good information source and stuff, but how long is it going to be more, you know, freedom of access? They're already having problems out there with censorship and closing off science and research and stuff, and you know, so there's too many people out there that don't want to live in a free society and access to information. So, but without that, you know, it doesn't give people a whole lot of reason. It narrows our society down to, you know, it's a very dull society. Well, that isn't available. But, all right, that does it for this session.